we're going to follow on from activity 3A and complete activity 3B, which investigates the effect of temperature and pH on the turnover of a marine animal. So a turnover response is a great simple way to assess the health and resilience and survival of marine animals, and it's simply just turning the animal onto its back or its shell and then recording how long it takes for it to go the right way up again. Today we'll be using the maihi, or the spotted top shell snail, which can be found along rocky shores all around Aotearoa, and we will be doing 4 different treatments and seeing the response of the turnover time for these animals. Here is a close-up of our study animal today, the maihi, or the spotted top shell snail. An easy way to identify these snails is by looking underneath and seeing these lovely checkered spotted patterns in white along the edge. You can see these spots from the top, but sometimes they have things growing on them or the colour changes with their lifetime, and so if you just flip it over, that's a sure way to identify them correctly. So for our experiment today, we're going to have 4 different treatments. We have a control treatment, so this is just the seawater that we got out of our taps today, the current conditions out in the ocean in the Otago Harbour. We have increased temperature, so this is some water that we've microwaved like we did in the previous activity. We have a treatment of lowered pH, so this is by blowing through the water with the straw. And we have a sample or experiment where we've got increased temperature and also lowered pH. And in each of our containers we have 4 snails, and so these are replicates for each of our treatments, and so replicates are really important part of doing an experiment. Before we go further with our experiment, we want to make sure that our snails have a chance to acclimatize to each of the different treatments. So we make sure that we put our snails into the treatments and leave them there for 15 minutes before we start with the turnover experiment, and this just gives them time to adjust to the different scenarios that we've put them in. We also want to make sure we have our data sheet ready, so you'll be recording all of your information on the other page. This is a great activity to do in groups, so if you're working with a big group or classroom, you can split them up and have each group look after one of the experiments. Each of the groups would then have a look at the behaviours that they've observed for each of their 4 snails and the turnover time, and then the data from the group or class would be compiled in this larger spreadsheet. Now that our snails have acclimated, we're ready to start with the turnover experiment. Make sure that when you are setting up your different scenarios that you are testing the temperature and pH, and that you've recorded that in your spreadsheet. We'll start now with our control. So we've got a spoon here which we use to lift the snails up and turn them over, and this is because handling them with our hands or touching their operculum, which is their little trap door underneath, can have some effects on the results. So what we do is we just scoop it up. You can see that its muscular foot is coming out, and now we stop. As soon as the snail rights itself and is completely on top of its foot again, we stop the timer, and we got 7 seconds and 59 milliseconds for that turnover time. So repeat that for all 4 snails and all your 4 treatments. Write down in your table, and then you can average your turnover time for each of the experimental setups down below. Make sure when you are doing the experiment that you don't create shadows over the animal and that you don't bump the table or the containers, because the animal can sense that and it will affect how the animal responds, because it will hide back in his shell. Now that you've completed activity 3B and you've averaged your turnover times for all your replicates and your different treatments, you want to see whether there were any effects on turnover time depending on the treatment that your snails were in. Did you find a combined effect? Did an increase in temperature and lowered pH in the same treatment have a different effect than just increased temperature by itself or just lowered pH? And how did that compare to your control, which is your ambient temperature and pH at the moment? You also want to think about the value of replication in the experiment. Why did we use 4 snails in each of the containers? And we talked a little bit about why we want to acclimatise our animals as well.